Hello and welcome back. So in the last video we tried to see how we can profile our code using the command prompt, okay, because we said we have two ways we can profile. We have two things to profile in code. For time, we profile our time, we profile the memory, and then we use this as an example, a program that is going to compute the sum of squares of the first n natural numbers. We tried when n is 3 and when n is 5, and then we got this result. So we wrote a program on this. We used this was a program we wrote. We wrote a program on this, and we tried to compute the amount of time it's to take this program to run using a command prompt. But however, in this video we are going to see how we can use the time model to profile our code instead of using a command prompt. Okay, now using the time model is general. It doesn't matter if you're on a Windows operating system or if you're in Linux or Mac. It doesn't matter. It's going to work out fine for all of this. So first we are going to create a new file, and I'm going to use Jupyter Notebook this time around. So I've already created a file here. I call it profile with time model.ipynb. So what we're going to do, this is how the time model works. If you want to profile the time model, you have a particular section of code you want to profile. You want to know the amount of time it takes to run. It could be a single line, it could be a block of code, maybe a function or so. So what you need to do is to record the time before the process starts. You record the time at which the process ends. Take the difference between this time. That's going to give you the amount of time spent on that process. So first we are going to import the time model. Okay, so we import time. That's the first thing we do. After importing the time model, now we need to record a particular process, see the amount of time that process took. So I'm going to say time start equal to, within the time model there's a function called clock. So basically they love using two. We can either use the time function or we can use the clock function. So the reason I'm using the clock function and not the time function is that the clock function measures the CPU time, okay, while the time function measures the actual time spent by your system. So the CPU time is always what we want to measure, to see how much time is spent by the CPU on processing your actual code. Okay, so that's why I'm going to take the clock function. So I'm going to say at the start of this process, this is the time I have. Then what do I want to do? What I want to do here is just to raise I want to raise 4 to the power of 20. That's what I want to do. Then I'll say end is going to be this same thing. So I have the time spent, the time before the process starts, the time after the process. Then my final result is going to be end minus start. That's going to be my final result, end minus start. So we're going to see how much time was actually spent on this process. So let's run that and see. And this took about 8.5 times 10 raised to the power of minus 5 seconds. That's what it took. Okay, so we are going to use this to profile the code we did in the last time, the code we wrote in the last time. So all I'm going to do is I'll move down to that file, copy everything I see here, everything I have here, copy it, bring it down to this file. Then I'll copy out this, run this function. Now I want to profile this function. So for me to profile this function, I'll copy this. I think that will be nice. Copy it, take it down here, save this, paste it. Then I'll replace this process by me calling this function, me executing this function. Okay, so let's see if that works out fine. So if I give it 3, let's see how much time it will take us to execute that. So that took us about 0.0003 seconds. So let's increase this to 100. Okay, and that took about 0.0086 seconds. Increases to, this is about 100,000. and 100,000 is about 0.086. So let's make it 1 million, and let's see. So 1 million will take about 0.6. You can see it's actually increasing. Okay, if I make that 10 million, I'm going to have this is going to fall into second, actually not 0 point something seconds, I think so. So this is giving us about 5.9 seconds to actually process this code. Okay, so this is how you use the time model to profile a particular section of your code. But what we want to do here, we want to compare the result we have here with some other method, and that's the basic reason we actually named this the use of profiling and using of formula. So most times when you're writing your code, once you're done writing this code at that very moment, you might think, hey, is there a way I can optimize this code since I've profiled it and I found out that it's actually taking more time to give me the sum of the first 10 million natural numbers? Is there a way I can optimize this code? And one good way you can optimize this code here is by using formulas instead of going through this process. For the sum of squares of the first n natural number, there's a formula we can actually use for that. Now this is not going to be the case for all processes you're working with, but always try to look out for a way if you can get a formula that can compute the process you're working on. Okay, so the formula we're going to use here is this. Instead of using this, we are going to use this formula, n into n plus 1 into 2n plus 1 all over 6. So if I substitute n as 3, I'll have 14 like the previous case. Substitute n as 5, I'll have 55. So I'm going to be using this formula, then I'll compare both cases and see if the formula is actually performing better or the process we have there is performing better. So let's see the formula and see what we're going to get. So I'm going to call it sum of natural, sum of squares of natural, sum of squares, let's call it modified, sum of squares modified. So it's going to take in n still, but rather this time around it will return n times, I think what we have there is n plus 1 times we have 2n, 2 times n plus 1, then divide all of that by 6. So let's test this and make sure it's working fine. So I'll call this function sum of squares modified. I'll call it with a 3. I'm expecting 14 as my result. I'll call it with a 5. I'm expecting 55 as my result. Okay, so which means it's working fine. So let's profile this and see how much time it's going to take for this same amount of code we have here. So to profile it, I can simply call this and then change the name to this other one, and let's see the amount of time it's going to take. So this is taking about 0.00034 seconds as against the value we have here, which is 0.590118 whatever. This is 5 point something seconds. So this 5.7 seconds, this is 0.0003. So this is far better. You can see this is faster compared to the other one. Okay, so one thing we can basically do, one more thing we could do is to compare the amount of time it would take these two to run. Okay, compare them. That means to say, okay, the other code, this is how many times faster compared to the other one. Okay, so I don't want this video to be long. For that reason, we are going to end this here, and in the next video I'll show us how to compare these two processes and see which one is actually better. Okay, so I'll see you guys in the next video. Bye bye.